If you want to use any hard disk, definitely you should format it before. Okay, otherwise, okay, so hard disk doesn't have a place, okay, or not place, okay, the proper place, okay, the proper place, okay, to what to say, proper place to store the data. So our proper structure to store the data. Okay, so that's the reason what we are doing. We're doing formatting actually. So we understood what happens when you format your hard disk. When you format your hard disk, it will be divided into tracks, blocks, and sectors. And you know what is the default block size and sector size? Default block size 4 KB, and the default sector size is 512 bytes. Okay, it means okay, each block will have 8 sectors. Okay, so this is what okay we have seen. Yesterday. Okay, correct. Okay, after that, okay, we slowly went to would slowly try to understand. Okay, so what happens okay, what happens when you try to store a file into your hard disk? When you try to store a file into hard disk. Okay, so what happens when you try to store your file into hard disk? Okay, so uh, it will be divided into. One second, please.
Pieces.
Okay, so it will be divided into blocks, small blocks. Okay, what is the size of the block? Okay, so based on your formatted size actually. Okay, so here okay, 4 KB by default it is 4 KB. So your whatever size of the file you put, let it be 1 GB, 1 TB, or okay, 10 GB. Okay, any size of the file. Okay, you store in the disk, it will be divided into 4 KB blocks by default. Okay, and divided into 4 KB blocks and stored into the blocks where okay we have free space. Okay, so these are all the blocks where we have free space. Okay, so it means okay, when you write a file, it is getting divided into 4 KB pieces and writing into free blocks. Okay, and again when you're writing a file, will you write only one file on the hard disk, or will you write multiple files? Definitely will be writing multiple files. So the problem comes here is that when you write multiple files, okay, so we don't know which blocks are used for which file actually. Okay, so that is the reason. So we have a concept called metadata. Okay, we have a concept called okay file allocation table. So this is a small table which will be maintained by every storage, every hard disk actually. Okay, this is a table, file allocation table, which contains information about your file. Okay, and what is the file name, what is the file path, okay, who is the owner, okay, what are the permissions okay, we have, and when the file is created, okay, size of the file, okay, which block numbers used on the hard disk for this file. Okay, all this information will be maintained here. Are you clear? All this information will be maintained here, and status of the file also, whether it is active or inactive. Okay, so to maintain this table, okay, this is called metadata. So to maintain this metadata table, Pratyusha, some noise. Okay, yeah. To maintain this metadata table, what we have okay. I mean, okay. So the disk is reserving some space actually. Okay, reserving some space. That is the reason. Okay, when you buy 1 TB hard disk, okay, after formatting, you will see only 925 GB. Okay, you will not see all 1024 GB space. The reason is so it is reserving. Your hard disk is reserving some space, okay, to maintain this metadata table, okay, which is nothing but file allocation table. Okay, so now if we have this table, okay, it is easy to understand. Okay, if I want to read sample1.txt, I'll go here. Okay, so when I double click the file on the file, first okay, reading algorithm will start, and okay, hand over this request to disk header. Okay, so disk header, okay, reading algorithm will check in the file allocation table. Okay, so what are the blocks related to sample1.txt? Okay, what are the blocks related to sample1.txt? It will see those blocks, and okay, it will request disk header, hey, can you read B46 to B50 and B138? These blocks, can you read and give it to me? Okay, so that's what the disk header reading algorithm will do. Now disk header work is reading the blocks here, and based on the request from reading algorithm, disk header will read the blocks and merge them into single piece and give it to reading algorithm. Now reading algorithm will show it on the screen. Okay, so this is what happens in the background for reading data. Are you clear till this? Okay, so what is the problem here? What is the problem? Okay, so we know how the data will be written on the hard disk, and we know how data will be read from hard disk also. Yes or no? Okay, so data is getting written in the form of blocks. Okay, and while writing the data, and first it is writing the data into blocks, free blocks, and and at the end it is updating the metadata table. Okay, so but while reading the data, first it is contacting metadata table and finding which blocks are related to your file, and asking disk header to read those blocks and give it to you. Okay, so that's how it is working. The problem, the write algorithm is simple, read algorithm is simple, but there is a problem here. What problem? Okay, see, in the initial days of your hard disk, in the initial days of your hard disk, you will get enough space, or you will get continuous blocks to write your data. Okay, but the more you use your hard disk, what will happen? The more you use your hard disk, what will happen? Okay, it will um, it will fill all the blocks like this, and you may not get continuous blocks to write your file. Okay, see, this is the case. Okay, let's say your hard disk is almost full. Now, you want to delete some data and write some other data into that place. Okay, so now you deleted these three files. Okay, so one file is one file cleared these blocks, second file cleared these blocks, third file cleared these blocks. Okay, so now your free space is not in continuous place. Okay, so some free blocks are here, some free blocks are here, some free blocks are here. Okay, so when you have blocks in different places, the problem here is that it will impact the writing performance as well as reading performance. Okay, so even if you want to write the data also, first disk header has to jump here. Okay, write these blocks. From here again it has to jump here, write the blocks. Again it has to jump here, write the block. Okay, so this is a big headache. Actually, this is a big headache for disk header. Okay, this will create a lot of problems, guys. Okay, so the performance of a disk will drastically go down. Okay, so this is the major issue actually. So what is the major issue here? So let us note down this major issues also. So major issues with the disk. First thing, so performance will be performance will be degraded over the period of time. Yes or no? Performance will be degraded over period of time. Okay, so this is the first problem. Okay, so due to sick. Okay, so why performance will be degraded over period of time? Due to okay, due to non-continuous block storage. Due to non-continuous file blocks. Okay, so performance will be impacted. Okay, will be impacted. Performance means so mostly C. Okay, will be impacted over a period of time. Okay, so this is the first issue, guys. This is the first issue where people found or where industry is facing. Okay, what is the other issue industry is facing? Any questions till now, guys? This is what we have seen yesterday. Okay, so we understood what is hard disk and so how the data will be stored here and how the metadata will be updated in the file allocation table. Okay, and what will happen when you don't get continuous blocks when your file is not stored in continuous blocks. Okay, when your file is not stored in continuous blocks, your disk header has to do a lot of jumps to read your complete file. Okay, so this will create okay, so more number of seeks, which causes delay in writing or reading the file blocks. Okay, so it's a seek time issue. Understood? Okay, so this is what we have seen. Okay, now let us go to the next issue. What is the next issue where industry is facing? Okay, so what if file size is larger than disk? What if file size is larger than disk? Let us take this scenario, guys. Okay, so when you started using your computer or laptop, guys, any one person, when you started using, or okay, maybe I'll give my example only. Okay, so I purchased my first desktop. Okay, that time I didn't purchase laptop. Okay, first desktop sometime in 2002. Understand, guys? 2002. I'm very old, guys. Okay, so 2002. Okay, so that time I purchased a desktop. Desktop. Okay, and the storage, the hard disk I had was 20 GB. Okay, 20 GB. Okay, so in this 20 GB, what we can store, guys? So that time, okay, we were not having good internet also. Okay, even internet also, very few people used to have internet, and okay, that is also very costly. If we download one song, okay, they used to charge nearly 4 rupees like that actually, 4 to 5 rupees one song if you download. Okay, so that much cost actually, that much costly. Okay, that time. Okay, so no internet. Okay, so 20 GB. Okay, for a student. Okay, for a student. Okay, 20 GB. That time it was good amount of space actually. Okay, but slowly. Okay, so slowly people started okay, collecting some songs and all. Okay, for student, what is the data? Maybe he may be having 1 or 2 projects data that will hardly take 200 MB, 300 MB. The rest of the things are like, okay, so MP3s, audios, okay, videos, okay, or movies. Okay, that time movies, okay, were not there. Okay, but okay, video songs was there actually. Okay, so what I used to fill, okay, I used to fill audios mostly. Okay, my project documents. Okay, audios and videos. Okay, so this is what, okay, this is the data for me. Okay, at that time. Okay, but later slowly internet also started. Okay, sometime in 2007. Okay, so 5 years I use this desktop, guys. Okay, I use desktop. Okay, so later, okay, what I felt, okay, I felt that, okay, this 20 GB storage is not sufficient. Okay, so 20 GB is not sufficient. Okay, so in between also my data got increased, but okay, so what I used to do, I used to back up my data into CDs actually. That time CDs were there, right? Okay, so I used to write, okay, let's say I have some excess songs. Okay, so I used to write into CD. So whenever I want to listen those songs, okay, I insert the CD in the CD-ROM, and I used to play the songs. Okay, but 2007, okay, so my data has become almost, okay, 50 to 60 dB, 60 dB. Okay, 50 to 60 GB. Okay, so in 2007, by the year 2007, okay, I felt that, okay, I'm using 50, 60 GB means, okay, 20 GB is internal hard disk. Okay, and again, okay, the remaining 30, 40 GB, just imagine how many DVDs we used to have. Okay, we used to have, so not DVDs, okay, only CDs actually. Okay, so I thought that, okay, say every time if I want to say, if I want to watch a song, okay, every time, okay, I cannot open my CD version. Okay, I can find my CD and insert that into my system, and okay, play the song. Okay, so this is okay. So my data is in. So here, okay, again, okay, my data is in hard disk. Okay, and okay, CDs. Okay, by this time. Okay. So okay, almost okay. So I used to have around, okay, 30 to 40 CDs actually. Okay, so 40 CDs. Okay, now, do you think that, okay, every time if you want to watch a song, okay, First of all, finding which DVD, which CD is having this song. Okay, and that itself is a difficult activity out of 40 CDs. Okay, and then okay, inserting that into CD-ROM and okay, playing it. Okay, so this is a big deal actually. So I felt that okay, hey, this will not work out. Okay, I'm unable to listen my songs whenever I want, unable to watch videos whenever I want. So what I thought, okay, okay, sometime in 2007, I upgraded my hard disk to 100 GB, the same desktop 100 GB. Okay, then okay, what is the use of this 100 GB now? What I can do? This is okay, by 2006. Okay, this is the status. Okay, so now 2007, yeah, upgraded. Okay, so this is the data size actually. Okay, this is hard disk size. Okay, this is data size. Okay, in 2006, this is the data size. Okay, so here also I had okay 20 GB, but okay, so the extra data and all I used to store in CDs. Okay, so 2007, okay, I upgraded my hard disk to 100 GB. Okay, why I upgraded my hard disk to 100 GB, guys? What is the reason? Can't I run with 20 GB hard disk and okay CDs?
Because that is more difficult to manage with the data, sir.
So more difficult to manage the CDs and all. Okay, so finding okay with CDs having this song. Okay, inserting that into system. Okay, it takes a lot of time.
And
Okay,
there may be a chance to damage those.
yes,
Yeah.
because of damage also. Okay. So as a student, okay, I like to keep all my data into one place. Will you agree with me?
Yes, sir.
Okay, so what I did, okay, I upgraded my hard disk to okay, so 100 GB. Then what I did, okay, I copied okay, all the data from my old hard disk and okay, all data from CDs to 100 GB. Okay, now okay, I'm happy because okay, all the data is in single place, and now I no need to find okay, okay, in which CD my song is available and all. Okay, I no need to find okay, everything is in my desktop. Okay, whenever I want to listen song or whenever I want to watch video, I can directly go to my drive and I can double click on it and I can watch it. Okay, so fine. Okay, later slowly what happened? Okay, so maybe sometime in 2010, okay, 2011, I guess. Okay, 2011 slowly. So I purchased my laptop. Okay, purchased my laptop. So I had okay 250 GB. Okay, that time I had 250 GB hard disk. Okay. Again, okay, the same issue. I felt that okay, so that time okay, 11 okay, slowly DVDs also started coming. Okay, so we used to write all of store all our access data into DVDs and all. Okay, so here discs and DVDs, not CDs now, DVDs. Okay, so then okay, so slowly okay, my data started increasing. Okay, sometime in 2015. Okay, so 15 okay, I extended this to 500 GB. Okay, so then 2016 okay, I started again. 16 I started my classes, extended to 1 TB. 1 TB HDD. Then okay, 17, not 17, okay, 18, okay. Then I made it like SSD. So 20, I felt that this is also not sufficient. I made it like 2 TB SSD. Okay. Understand? Okay. So when that is costly, yes, okay. Every time what is happening, okay, every time okay, my data is increasing. Okay. I'm upgrading my hard disk actually. Okay. So what did you understand from here?
Sir, because day by day, data, I mean, storage data is increasing, thereby we
Day by day.
keep on updating.
So now tell me, see where we started, where we are here. Okay, we started with 20 GB, and okay, we are here okay, at okay 2048 GB. Okay, and okay, so if we start going further, okay, maybe if we start loading more and more data, yes, okay, tomorrow I may have to purchase okay 5 TB SSD. Yes or no?
Yes, sir.
Okay, so this is the one simple common man's requirement. Okay, common man's requirement. Okay. Just imagine about the company, a company who is maintaining a lot of data.
Sir,
So
then this will be, I mean, a huge problem for that company. Is there any solution to overcome this type of
yes, sir.
issues?
Yes, sir. We will see. Okay. So for definitely companies, okay. So initially, okay, so there are many companies. Okay, you take an example. Okay, so one of the biggest company, okay, like Reliance. Okay, you take. Okay, so just imagine. Okay, Reliance data. Okay, how much data they get every day. Okay, so yes, okay. When they started, it may be like okay, 10 TB. Okay, 10 TB. Okay. So again, okay. So later, okay, it is increased to 20 TB. Okay, so let's say increase to 30 TB. Okay. Okay, like this, okay, it is increasing. Okay, now 100 TB storage. Okay, so now 1 petabyte storage. Okay, it means okay, my data is still increasing, correct?
Yes, sir.
So now in market, okay, if you buy any storage, okay, hardly you will get okay. So I guess okay, 10 PB is the maximum storage you will get, single storage you will get. Understood? Okay, it means okay. So if Reliance company data is increasing day by day or month by month, okay, so one fine day definitely they will cross this limit. Yes or no? Huh?
Yes, sir.
Okay, when they cross this limit, okay, see, and again, okay, these companies also, they're happy to keep all their data in one place or not. And okay, so they all feel like okay, so all my data should be readily accessible for each and everyone.
Yes,
Okay,
sir.
so they want to keep the data available. Okay, keep the data everything in one place. Okay, and the data should be readily available to be accessed by all the people. Okay, so now imagine. Okay, so this is the maximum storage disk. Okay, I can get in the market. I can get in the market. Okay, now what in case? Okay, if Reliance data has become 20 petabyte, what they will do? What they will do? So yes, okay. So the data has increased now. Okay, but okay, they have money to buy 20 petabyte disk storage also. But do you have 20 petabyte storage manufactured in the market?
No, sir.
Then how they will store all their data into a common place? Hmm? Got my point, guys?
With the array of storage, sir?
So
No, they
no, no.
have to
Uh, Tell me.
new new desktop, new laptop.
Sorry. See, one thing is that okay, suppose okay, tomorrow if my data is okay, 100 petabytes, I can buy it, okay, 10 petabyte storages and I can store, right?
Yes, we have to do like one more 10 petabyte.
So it means you need to buy, okay, if my data is 20 petabytes, okay, you buy one more 10 petabytes and store your data there. But the problem here is that it is not in common place now. Yes or no?
And sir, it is not in common place as well as even after I mean, after filling up that another 10 petabyte also, same problem will happen.
Of course, yes, okay. So like this, okay, so I'll be having, okay, so one fine day, okay, Reliance, okay, will have, okay, so like this, okay, so many 10 petabytes, like how I had, okay, 40 CDs. Yes or no? So in 2006, okay, I used to have okay, 40 CDs, songs and all, songs, movies, audios, videos, all these things, okay. Like that, okay, even Reliance also, one fine day, Reliance also will have 40 10 petabyte storages. Okay. Again, okay, what are the problem I faced? Okay, whenever I want to listen a song, I need to find first, okay, in which CD my song is there. In the same way, in which petabyte storage, okay, in which storage, okay, my data is available. So again, whatever the common man problem, okay, common man, okay, what are the problem common man faced? Even okay, Reliance also will face the same issue when they store their data into separate storages. What to do? Okay, and this is one of the problem. Okay, came to Google also. You see Google, okay, how much data Google might be having, guys? How much data? Just imagine.
So it's very difficult, sir.
So petabytes of data. Okay, so how much results it will show? Okay, so you type something. Okay, so you type okay anything. Okay, so okay, so what I can say? Okay, okay, let's not bring politics. What I can do? Okay. Mahatma Gandhi. Okay, I'm just typing. Sorry guys. Okay, so see, when I type Mahatma Gandhi, see how many results it has given me. Almost 3 crore 95 lakhs results it came. It has given me. Correct? Yes or no?
Yes, sir. Yes, sir.
It has given me 3 crore 95 lakhs results. Okay, and that too in 0.55 seconds. Okay, so it means all this information Google is having right now.
Yes, sir.
Yes or no? So
Yes,
it
sir.
means so about one word, one word, one name, Mahatma Gandhi. Okay, this is the name I typed. Okay, it gave me this one. But okay, you type anything in the world. Okay, Google will give you some replies. Yes or no?
Yes, sir.
Okay, it just imagine now how much data Google might have had. Correct. Huh? So how Google is managing all this data? So is it the same way Google also doing? Okay, so if you type Mahatma Gandhi, it is checking in okay here, then it is checking here, then it is checking here, then it is checking. Is it the same way it is doing?
No, sir. If
No.
if it is checking like that, means it will take more time.
Yes, it will take more time. Okay, so it means okay.
The cloud storage solution for this.
Cloud storage solution has come just now, sir. Just now. Okay. So do you have cloud? Okay,
Maintenance warehouse.
2002, 2003.
No, sir.
Maintain the warehouse.
Okay. Yeah, this is warehouse, sir. Each 10 petabyte is one warehouse. Correct. That's the maximum warehouse they can maintain. Okay. So, okay. So this is one of the problem. Okay. Whatever I have told here, this is one of the major problem. Okay. Faced by Google also. Okay. And that time, okay. See, we had many search engines in market, okay, but still Google is the top search engine in the world. Okay. So Google was growing at that time. Okay. But okay. So Google want to almost reach #1, but okay. It has to continue its place in the market. Okay, that I am the first or the best search engine in the world. Okay, so what Google has thought, okay, hey, the way of storing data like this is not at all good. Okay, so not at all good. Okay, we need some other solution. Okay, this is not the solution for us. Okay, we need some other solution. What is that some other solution? Okay, so now okay, we will do the one thing. Okay, one more thing. So we'll put the problem statement now. What is the problem here? Okay, so what if file size is larger than the disk? Okay, so what your data is larger than disk? Okay, so this is the problem. Okay, so why I'm saying okay, data is larger than disk? Okay, see here. Okay, see, I changed my okay. See every time. Okay, see now I purchased the 1 TB hard disk in 2016 and 2018 I changed to 1 TB SSD. Okay, so do you think okay I upgraded my hard disk okay, because of a damage? No, this 1 TB hard disk still with me. Understood? Still with me. Okay, but okay, this 1 TB SSD still with me. Okay, even though these are good. Okay, I upgraded because okay, so these are not satisfying my requirements actually. Okay, so here also every company okay is facing an issue like okay, so they're unable to store all their data into one place. Okay, so when their data is growing okay larger than their disk capacity, every time what they're doing okay, so so need to change the disk okay whenever my data is growing. This is the second problem. Okay, every time okay, if I'm keep on changing the disk okay, one is okay money waste. Second thing is that okay, one fine day we may not get enough storage for our requirement in the market. See here okay, see the Reliance problem. Okay, so in the market we have only 10 petabyte storage, single storage. Okay, so but okay, if Reliance data is more than 10 petabyte okay, they have to store in two boxes, not in one box, or two disks, not in one disk. Understood? Okay, so these are the problems. Okay, so Google also started facing this issue. Okay, one is performance issue. Second thing is okay, kind of financial issue. Okay, kind of data consolidation issue. So these are the two problems, okay, where industry was facing. Not only one company, guys. Okay, entire industry, entire world is facing these two issues. These two issues, okay, in sometime in 2002 and 2003. Understood? Or any questions till now? Understood or any questions?
Understood, sir.
Okay. So now, okay. So now we need a solution for these problems. Yes or no? Okay.
Yes, sir.
So what is the solution, guys? Please don't tell me cloud, sir. Okay, cloud came. I don't know who spoiled your brain. Okay, yeah. Okay, so cloud came. Okay, just in recent days, guys. Okay, so what is the solution? How we can overcome this problem? Okay, so my requirement is that, okay, I want to keep all my data in one place. First thing. Okay. Okay, I want to keep all my data. I don't want to keep segregate my data. Okay, 10 petabytes, 10 petabytes, 10. Okay, I don't want like this. I want to keep all my data in one storage. Okay, so this is my first requirement. Second thing, okay, performance should be good. Okay, so here, okay, so here I'm not storing all my data into single storage, and performance also not so good because, okay, every time I'm searching here, searching here, searching here. Yes or no? Separately. Okay, this box doesn't know what is stored here. This box doesn't know what is stored here. Okay, all are separate boxes. Okay, they are not interlinked. Okay, and okay, searching. Okay, log into each box and, okay, searching for your data will take a lot of time. Okay,
By
so
making
performance
connecting
of
all
problem.
these, so by making connecting all these and giving access to the individual systems.
Okay, okay. How to connect all these things? Yeah, idea is good. Okay, how to connect? Who will connect? How to connect? Okay, so
data warehousing has the concept of horizontal scalability, right? I mean, it's going to
what is this horizontal scalability, sir? Where is this
like
concept?
you can add the nodes, you can increase the scalability by just adding the nodes and adding the storage to it.
Yes, sir. Okay, we know that, okay, scalability is there. Okay, but how it works? That's what the concept here, right?
Okay.
See, you all understood cloud. Okay, you all understood, okay, scalability. You all understood, okay, connecting all these things into one box. Okay, but how internally they work? If I say, hey, okay, if I put a just a one mantra and say that, hey, you all interconnect, will they interconnect? Huh?
No, sir.
All right. Okay. So what Google has done? Okay, see, this is one of the major problem for Google. One of the major problem for Google. So what Google has done that time? Okay, they have come up with one idea, guys. What is this idea? Okay, so what is your process here? What is, okay, how the disk storage is working now? Let us see this statement. Okay, how disk storage is working? Okay, how it is working? So disk storage will have two parts. No. One is, okay,
Yes,
when I
sir.
say disk, okay, this is metadata area. Okay, this is the metadata area. Okay, and this is the
Actual data.
actual data. So now, okay, all together, okay, we call it as a hard disk. So no. So what is my hard disk? Can I say this is my hard disk? So you take any hard disk, any storage medium in the world. Okay, this is how it is designed. You will have some area for metadata, some area for actual data. Okay, so whatever data you write, okay, so your data will be written into this one. Okay, your actual data will go here. Okay, so whatever data you write, okay, so let's say for example 1.txt. Okay, any data. Okay, so let's say it is 1 GB. Okay, 1 GB size. Okay. This 1 GB data will be divided into 4 KB blocks. 4 KB blocks and stored into actual data area. And okay, once the blocks are completely stored, okay, what are the blocks used for this 1 GB? That information will be updated in the metadata area. Okay, is this point clear? Is this point clear?
Yes, sir.
Huh?
Sir.
This point is clear, right? So let me open this. Okay. So this is the actual concept of a hard disk. Okay. Now, just imagine, can we do something? Can we extend this concept? Okay. If we think out of box, okay, if we get something on this, okay, what to say? If we get something, okay, that will save our life. Yeah. This is the hard disk. Okay. So what we can do now? What we can do? Okay. So this is the hard disk. Okay. Now, can we separate, okay, metadata and actual data? Yes. Can we separate metadata and actual data? Tell me.
No, sir, I think.
Huh?
No, sir.
Okay. So fine. Okay. So okay, Google has done here, what Google has done, okay. So it has taken, okay, so it has written one software, guys. It has developed one software. So who developed this software?
Google.
Developed software. Okay. What that software will do? Okay. What that software will do? Okay. So that software, okay, will have multiple hard disks like this, guys. We have multiple hard disks like this. Okay, so here these are multiple hard disks. Okay, so okay, keep okay one more hard disk here. One more hard disk here. Okay, so now how many hard disks I have now here? Total 7 hard disks I have. Correct or not?
Yes,
7
sir.
hard disks I have. Okay, and okay, so and because of this Google software, if we ask okay each hard disk to change their characteristics, okay, what is the hard disk characteristics? Metadata, actual data, metadata, actual data. This is the hard disk concept. Okay, because of this Google software, okay, Google software, okay. So if I ask hard disk to change their characteristics, will it change? No, right? No, right?
No, sir.
No. Okay. So it will not change. Okay. So the hard disk are hard disk like this only. Okay. But what they started doing this, okay, using this software. Okay. See, physically I cannot make okay 1 TBs into one single 2 TB hard disk. Correct or not?
Yes, sir.
Physically, so can I take okay? See, can I take 2 hard disks like this and I can make it okay 1 2 TB hard disk physically? So I'll take
No,
okay
sir.
like this scenario. Okay. So I have okay one hard disk. This is one hard disk, a physical hard disk, and I'll take one more hard disk. Okay. Can I okay, so I will put a plus here. Put a plus here. Okay. Can I make it like okay 2 TB hard disk here?
No, sir.
I cannot make it like 2 TB hard disk. Physically, I cannot do anything. Physically, I cannot make anything. I cannot physically combine these two into, so this is 1 TB, okay, 1 TB. This is also 1 TB, okay. Okay, so okay, I want to make it like this is 2 TB. Okay, so physically, this process is not possible. This is an impossible concept. Yes or no?
Yes, sir.
Impossible concept. Impossible concept. Okay. So now okay, since it is impossible concept, what they have done, okay, so they developed a software, okay, so to this software, okay, so what this software will do, this software will connect all these disks into a single unit, guys. Understood, sir? Okay, so this disk, okay, this disk, okay, will connect, okay, all these disks into a single unit. What do you mean of single unit here? What do you mean of single unit?
Entire hard disk will work as a single hard disk.
So entire?
The entire hard disk work act as a single.
So all hard disk here, okay, will act like a, okay, all together. Okay, so now, okay, so think like this. Okay, so this is 1 TB, okay, 1 TB storage. Okay, okay, this is okay, 1 TB storage. This is okay, 2 TB storage. Okay, this is okay, 2 TB storage. This is 5 TB storage. This is 5 TB storage. Think like this, guys. Okay. So again, this is 1 TB storage. 1 TB storage. Okay. So now, okay, so this is the software. This is the software which can combine all the physical systems into a logical disk. What do you mean of logical disk, guys? What do you mean of logical disk? Huh? What do you mean of logical disk? What is physical hard disk? So this is physical hard disk. Okay, physical hard disk. Okay, or this is physical hard disk. Okay, but what is logical disk? Okay, now, okay, see now this is 1 TB, guys. Okay, if I ask, okay, if I ask this hard disk, okay, what is your total capacity? What it will say? If I ask this, what is your total capacity? What it will say? My capacity is 1 TB. Okay, if I ask, okay, this individual hard disk, okay, what is your capacity? It will say 1 TB. If I ask this hard disk, individual hard disk, okay, what is your capacity? It will say 1 TB. Correct?
Yes,
Correct
sir.
or not?
Yes,
Okay, but okay, if I ask, okay, this software, okay, because this software has, okay, 7 disks under it. Okay, if I ask this software, okay, so what is your total storage? It will give me an answer like, okay, so 1 plus 1, 2, 4, 6,
17.
17.
17. Okay, it will give me answer like, okay, my storage is 17 GB. Understand?
Yes, sir.
Okay, so Google developed a software. Okay, so where, okay, it can combine multiple physical hard disk into a single logical storage. Understood? Single logical storage. Okay. Till this you are clear, right? I hope you are clear.
Yes,
Sir,
sir.
which software is that?
Huh?
What is
Sir.
the name of the software, sir?
Give me some time, sir. Okay, give me some time. Okay, so there is no name for this software and all. Okay, so here they developed something. Okay, we will see. Okay, now what is the idea here? Okay, this software is good. How this software will work? How this software will work? Okay, so see, any physical storage. Okay, when I say physical storage, okay, any storage. What is the concept of storage? Normally, when I say storage is equivalent to combination of
Metadata and actual data.
Actual data. Actual data. This is the concept of a storage. Will you agree with me? Okay.
Yes, sir.
Okay. The physical disk. The physical hard disk. Okay. How this concept will work? Okay. So in the physical hard disk, okay, you will have metadata plus actual data on the same place. Sir, no.
Yes, sir.
So if you see the physical hard disk, okay, the metadata plus actual data, both are on the same place. Both are in the same place. Okay. Same disk otherwise. Okay. Okay, so physical storage. Okay. Now let us take logical storage, guys. Okay. So when I say storage, okay, so what it should have? Metadata, actual data. These two, right? Okay. But now when I say physical storage, okay, you have, this is physical hard disk. Okay, so you have metadata and actual data. Okay, metadata, actual data. Okay. Now when it comes to logical storage, how this metadata and actual data will work? Okay. So here, okay, what they did very simple step, guys. Okay. Metadata in one disk, one master disk, okay, plus okay, actual data in some worker disks. Understood? Here, what they have done, guys? What they have done here? So here, okay, I have total 7 hard disks. Out of these 7 hard disks, okay, so I am making this hard disk as, okay, I am making this hard disk as master disk. Okay, I am making this disk as a master disk, guys. I am making this disk as a master disk. Okay. So here, okay, so we need to tell which disk should be acted like a master disk. Okay, into the software again. Okay, who will configure this software? Who will configure this software? Okay, we have to configure. Okay, and we should tell, okay, which disk should be master disk and okay, which disk should be worker disk. So I'm taking it like okay, worker disk. Clear, sir? Any questions? Okay. So here the idea here is that okay, store the metadata into master disk. Okay, metadata on the master disk. Okay, metadata in master disk. Okay, and actual data in worker disk. Okay, so I made this disk as a worker disk. Worker disks. Clear? Clear? Are any questions? Tell me, guys.
Clear, sir.
Clear, right? Okay, so this is what okay this software will do. Okay, so this software okay will take okay multiple physical disk as an input and okay convert them into a logical storage. Okay, now tell me here. Okay, when you ask okay if this is total disk is 1 TB. Okay, if I right click on this one, okay, will it show metadata disk or okay only actual data storage? If I right click on this disk, okay, it will show only 924 GB, correct?
Yes, sir.
So it means it will not show metadata part actually. Okay. Here also, so here okay, we told that okay, this logical storage, okay, total logical storage, okay, we told 17 terabytes, right? Okay. Here also it is the same rule. Okay. When you show this total logical storage, when you see the total logical storage size, it will not show 17 TB, it will show 16 TB. Okay. So why it is showing 16 TB? It is ignoring this master disk, metadata disk. Are you clear? Or any questions till now?
Clear, sir.
Okay, so it is showing okay. So total logical disk storage is 16 TB. That is combination of all worker disks here, all worker disk. Okay.
Sir, I have a doubt.
Yes, madam, please.
In master disk, again the metadata will be stored for the metadata.
Okay, I didn't go to that
like
level.
already it has a metadata. And
No. Okay, I didn't go to that level. Okay, so I will explain now. Okay, what will happen here? I will explain
Okay, sir.
what will happen. Okay, so how the data will be stored in this logical storage. I didn't explain that till now. Clear?
Okay, sir.
Okay. So now, guys, okay, you got an idea first. Okay, what Google has done. What Google has done. See, now, okay, we have one beauty here. Okay, we have one beauty here. Okay. See, whenever okay, see, okay, fine. Okay, so okay, we'll come to that part later. Okay. Now let us see how to store the data into this logical storage. Okay. Now, when all the physical disks are connected as a logical storage, okay, so we will call it like how the data should be stored in the logical storage only, right? Okay, so now first, okay, question here, okay, how the data is stored in, okay, so first, okay, let us see how the data is stored in the physical disk. Physical disk. Okay, if I understand this one, okay, I can easily understand this one also. Okay, data will be stored, okay, in physical disk. Okay, what you will do first to store the data? Okay, so okay, what you will do, guys? So okay, so press Control V. Okay, think like this. Okay, press Control V. Okay, I'm just giving example, guys. Okay, press Control V. It means, okay, so this is okay. So initiate writing algorithm. Okay, pressing. Command. Okay. So initiate the writing algorithm. Let's say you want to write some data into this hard disk. Okay, what you will do? Okay. So you will initiate the writing algorithm. It means by pressing Control V. You can say Control V. Okay, so Control V means paste the data. Okay, Control V. That's the one thing. Or using commands also, I can initiate, right? I can copy a file from one place to other place. Okay, so now you are initiating the file write request. Okay, writing algorithm. Okay, so what writing algorithm will do now? Okay, writing ALG. Okay. Here I'm saying WA, writing algorithm is okay, WA. Okay. So now what? Okay, writing algorithm, WA algorithm calculates, okay, how many 4 KB blocks required. Okay. What? Okay. Check the size of input file, size of the file, and calculate the size of and calculates how many 4 KB blocks required to store this file. Yes or no? Yes or no? See, you are initiating a command. Okay, you are saying Control V. Okay, so Control V means, okay, immediately writing algorithm will start. Writing algorithm will check the size of the file now. Okay, let's say. So now, okay, you take this scenario. Let's say, where is this one? Okay, so this is the file. Okay, let's say right click on this one. Okay, so what is, okay, show more options. Okay, properties. Okay, the size of the file is how much here? Size of the file is okay. I will take, okay, so some file. Okay, Venkata's passenger list. Okay, I will take this file. Okay, so right click on this one. Okay, so now when you will say Control C and you will say Control V. Okay, when you press Control V, okay, where is the algorithm it is invoking, guys? Where is the algorithm invoking? Are you able to say algorithm invoking? No, right? Okay, we will do one thing. Okay, we'll take one movie, any movie. Okay, so what movie I can take? Okay, so I will take, okay, Bahubali 2. Okay, I will say Control C. I will say Control V. Okay, you see the algorithm now? Algorithm window invoked or not?
Yes, sir. It's no.
It's so this is algorithm actually. Okay, when you press, okay, see why this algorithm did not open there. Why this window did not open? The window means, okay, okay, see in Windows, in Microsoft Windows, okay, each algorithm will be like UI. Yes or no? Okay, that is the reason if you are seeing a pop-up window saying that, okay, copying this file from here to here, and it is showing the progress also. Okay, 10% completed, 15% completed, 20% completed, like that. So that is nothing but, okay, the writing algorithm. It is writing the data. Okay, it is writing the data. Okay, so now the question here is that, okay, so when you type this command, when you say Control V, first, okay, writing algorithm will open. Okay, and okay, it will check whether we have what is the size of this file. Second thing, okay, and okay, check, okay, how many check how many four require this one. Okay, how many 4 KB blocks are required to store this file. Okay, okay, so okay, instead of this one, okay, check the size of file and okay, and check whether we have enough space on the disk to write this data. So no, so writing algorithm, what it will do, it will check the size of the file first. Okay, then it will check, okay, and check, okay, whether we have enough space on the disk. Check the okay, so algorithm compare, okay, the size of the file and space on the disk. Right point, right? Okay, so writing algorithm compare the size of the file, okay, and free space on the disk. Okay, so if we have enough free space, if disk is having enough space, okay, if disk is having enough free space, okay, space, okay, so writing algorithm checks whether the required, okay, so whether, okay, so where the free blocks are, where the free blocks are available on physical disk. Okay, disk is having enough free space. Okay, now writing all the check, okay, where the free blocks are available in the physical disk. Okay, so now, okay, so now if 4 is okay, okay, so writing algorithm splits the file into 4 KB pieces. Okay, writing algorithm, okay, inform the disk header to write these pieces into available free blocks. Okay, so once okay, now disk header 6. Okay, so right, okay, so disk header will write the pieces. Okay, so once all the data is written, once all data blocks written, okay, commit the entry in the file entry in file allocation table with block number details, with block numbers. Sir. Okay, is okay, and close the close writing algorithm. Sir, is it this is what, okay, happening in the physical disk? Yes or no? When you
Yes,
try
sir.
to write the data, okay, what you will do? So you will, by pressing Control V or by pressing some command, okay, so you will invoke the writing algorithm. Okay, what this writing algorithm will do? Writing algorithm first, okay, it will check the size of the input file, okay, and okay, it will check compare the space on the disk. If the disk is having enough free space, then what it will do? Writing algorithm will check where the free blocks are available on physical disk. Okay, if 4 is okay, so the writing algorithm will split the file into 4 KB pieces. Okay, and okay, inform the disk header to write these pieces into available free 4 KB blocks. So now disk header will write all the blocks into these 4 KB blocks. Okay, so once all the data blocks are written successfully, commit the file entry in the file allocation table with the block numbers. Yes or no? And close the writing algorithm. This is what commit the file entry means. This is what the file entry. Okay, sample1.txt. Okay, so D drive Venkata. Okay, so like this actually, block number B46, B15, B138. Okay, so active. Okay, this is the commit. Okay, metadata entry. Okay, entry in the file allocation table. Okay, so this is what the normal data writing algorithm. Okay, so now the same algorithm, how it works in the logical layer. Understood, guys? Okay, the data is stored in a logical disk. Logical storage. What is logical storage here? All this together is the logical storage, correct or not?
Yes, sir.
Okay, logical storage. Okay, how data is stored in logical storage? Okay, so now, okay, so now what users will do? So users will, okay, any user, okay, so user will initiate the writing algorithm. So maybe by typing some command. Okay, now this is the writing algorithm. Okay, so now this is the writing algorithm. So this is the writing algorithm. Okay, initiate the algorithm. This is the writing algorithm. We are initiating it. Okay, so we are initiating it. Okay, so it means user means okay, think that as a Venkata. He typed some command. Okay, so some command, some writing. Okay, so some command. So just type some command. The command has invoked the writing algorithm. Okay, so you want to write okay sample.txt, sample1.txt, which is of 256 MB. Okay, 256 MB. This is the file, guys. This is the file, okay, where Venkata wants to write. Okay, so he has written a command and pressed enter in the, okay, so in the background what happened? Okay, slowly, so he invoked the, by using the command, he invoked the writing algorithm. Okay, what writing algorithm will do now? Okay, so writing algorithm will compare the size of input file. What is the size of input file here?
256 MB, sir.
256 MB. Okay, so here, okay, I'll bring a little bit. Okay, we'll check the size of the, okay, writing algorithm will compare the size of the input file. Okay, input file is 256 MB. Okay, yes, very important concept. Don't disturb. Who is this? Lavanya Shiv Prasad. Please be on mute. Okay, so writing algorithm compare the size of input file and okay, check and okay, and free space on the logical storage. Okay, now what is the free space on the logical storage, guys? What's the free space on the logical storage?
16 GB, sir.
16 days.
16 TB. Okay, now again, okay, if I ask, okay, each okay, so 16 TB, think like this. Okay, so now, okay, it is check the free space on the logical storage. Okay, so if logical storage is having, guys, okay, the same algorithm, guys, same algorithm. Okay. Logical storage is having enough free space. Okay, enough free space. Okay. Is having enough free space. Okay, writing algorithm checks whether free blocks are available in the physical disk or not. Okay, so writing algorithm checks, okay, so free, not okay. So okay, where the free space is available on physical disks. What does it mean? If logical storage is having enough free
Individual.
space, it means okay, logical storage is having enough free space. Okay, now, okay, writing algorithm will check, okay, where the free space is available on the physical disk. Okay, now, okay, so now I have, okay, 1 TB, 1 TB, 1 TB here. Okay, there are chances that it can be used also, right? Okay. This is the one. Okay. This is the total storage. Okay. This is the total storage. Okay. But okay. Now, okay, this disk might have used it, right, already.
Yes, sir.
That, okay, these are okay. Somebody also copied some data here. Okay. So think that, okay, what is free space here? Okay. At this moment, okay, think that, okay, 1 TB, 1 TB only. All 1 TB, 1 TB, 1 TB, 1 TB, 1 TB, 1 TB. Okay. Sorry. Okay. Whatever we have here. Okay. So it will see. Okay. Now it will check. Okay. It will check where the free space is available on the physical disk. Which physical disk is having space to write my data? Okay, which physical disk? Okay, so if you see here, all physical disks are having, okay, this is total space, okay, and free space. Understand, sir?
Yes, sir.
Total space and free space. Okay, so total space of the disk and like a free space in the disk. Okay, so free space means, okay, will it be 1 TB here?
Yes, sir. 1 TB.
No. Here, okay, metadata. See here, 925 GB, 924 GB. Total space of the hard disk is 1 TB, but okay, in that, okay, after format, how much free space it will show? Well, 924 GB, right?
Yes, sir. But master disk is acting as metadata for all.
No. Okay, see, that's what I'm telling, sir. Okay, sir. Okay, since okay, all these disks are working like a team. Okay, does it mean okay, it will change the characteristics of each disk?
No, sir.
Sir, okay, you are working as individual, sir, and you are working in a team. Okay, your name is your name only, right?
Yes, sir. Got it.
Got it, right? Okay, so even though you work, okay, as an individual person, okay, you work like a team. Okay, end of the day, you are you. That's it. Yes or no?
Yes, sir.
Okay, so here, okay, so it means okay, every disk follow the same standards. Okay, normal standards. Each physical disk will follow the normal standards. Okay, so now if it is 1 TB, what is the free space? 924 GB. Correct? Correct or not?
Yes, sir. Correct.
This is the total space, but free space is 924 GB. Okay, available space. Is this making sense now? Available space 924 GB. Even though you purchase 1 TB hard disk, you will not get enter 1 TB. 924 GB is available. Here also 924 GB. Okay. Here and okay, 1848 GB is available here. Okay, 1848. Okay. So here 5 TB means okay. So 5 into 462 GB. Yes or no? Okay. So
Yes,
now, okay, what is your total logical storage space? Okay, it is not okay 16 TB, guys. Okay, this is this much. Okay, so what is total storage? Okay, so 924 plus 924, 1848, okay, 8, okay, 4620, 4620. Okay, so this is okay, so 14.784 GB, 14.784 GB. Okay, is equivalent to by 1024. Okay, 14.5. Okay, 14.5 TB. Understood, sir? Now,
yes, sir.
so now I have okay. So total free space available space available here is this much 14,784 GB altogether. Okay. So now, but I want to write 256 MB. Okay. So now, if you see this writing algorithm is comparing the size of the input file, okay, with the size of okay storage available. Okay, okay, free space available on the logical storage. So 256 MB here, okay, 14,784 GB or 14.5 TB. Okay, yes, we have enough space. Okay, so if logical storage is having enough space, okay, if logical storage is having enough space, okay, now Now writing algorithm will check, okay, whether the free, okay, where the free space is available. Okay, if you see here, in all the hard disk, okay, we have free space, correct or not? In all the
Yes,
hard
sir.
disk, okay, we have free space to store this 256 MB. Yes or no?
Yes, sir. We have.
Yeah. So
Yes, sir.
now, okay, it is in all the places it is there. Okay, if 4 is okay. Okay. Now writing algorithm will split the data into file into 128 MB pieces, guys. Writing algorithm will split the data into how many pieces? 128 MB pieces. Okay. So writing algorithm. Okay. So here, okay, there is a trick. Okay. Writing algorithm. Okay. Writing algorithm in, okay, gives a unique name, block name for each piece, okay, and informs, okay, the physical disk, okay, the selected physical disk header, okay, physical disk, okay, to write the piece into its storage. See the statement, okay. So now, okay, now data is getting divided into pieces, guys. Data is getting pieces, okay. Sample.txt file is 256 MB. Okay, now it is getting divided into two pieces, okay. Piece 1, okay, piece 2. So no, piece 1 size is how much? 128 MB. Piece 2 size 128. Okay. So now, can I write this piece into any hard disk without a name? Can I write a
No,
piece
sir.
of data without name?
No, sir.
No. Okay. So you should give some name. Okay. So that is the reason what it is doing. Okay. What writing algorithm? Okay. So writing algorithm will give a unique block name for each piece. Each piece. Okay. And inform the selected physical disk to write this piece into its storage. Okay. So what writing algorithm will do? Okay. It is cutting the data into two pieces. Okay. It's cutting the data into two pieces. Okay. And it is giving a name like this case. Okay. Some name, some random name, BLK, okay, 001. Some name it is giving, BLK 002. Some unique name it is giving. BLK 001, BLK 002. Okay. So now, okay. So here, writing algorithm is giving a unique name, block name for each piece of data. Okay. Each piece of data. And it informs the selected physical disk to write this piece. Okay. So now, okay, so what the writing algorithm is doing? Writing algorithm is informing. Okay. So here, okay, how it, so to selected physical disk. Okay. So what is selected physical disk here? Okay. So selected physical disk is nothing but, okay, out of all the 6 disks, who is having more free space? Who is having more free space, guys? Okay.
You lost it.
Disk
The
2.
last one.
Okay. Worker disk 3, worker disk 4, worker disk 5, worker disk 6. Okay. So worker disk 5 and worker disk 6 are having the more free space, correct?
More space.
Okay. So what it will do? What it will do? It will give this first BLK 001. So now, okay, it will ask this Santosh. Okay. So it will ask, okay, writing algorithm is asking this disk, okay, hey, you write, okay, this piece of data, okay, into your storage. What is the name of this piece? BLK 001. Understood, sir?
Yes, sir.
So now, okay, so it is asking, okay, it is asking whom it is asking. Writing algorithm is asking disk, actually, worker disk. Worker disk, okay. So now, okay, what worker disk will do? See now, okay, here Now this algorithm will come into picture. What this work? Okay, how the data will be written in the disk, the normal one single hard disk. So here it is giving block one here. Okay, think like this. Okay, block one here, and okay, it is giving block 2 to this hard disk. Fine, sir. Sir, it's the same thing,
Yes.
right? Okay, it is not writing. Okay, in this scenario, in the single hard disk, okay, all the blocks are written in the same hard disk.
Yes, sir.
Okay, but okay here, okay, so here the okay here, okay, here the blocks are stored in a single disk or multiple disk.
Here it's storing in multiple disks, sir.
Multiple disk. Okay, so store the selected physical disk. Okay, so now once all the data blocks are written successfully in multiple disks, okay. So once all the blocks are written successfully in the disk, it is a single disk, but here it is a multiple disk. Okay, commit the file entry into into where? Okay.
File allocation level.
Centralized file allocation table. What is the centralized file allocation table? Okay, centralized file allocation table is another file. Okay, here. Okay, centralized file allocation is another file here. Okay, so now, okay, what this will contain? Okay, so this will contain something like this. Okay, this is the content of this one. Okay, this is the table it will have. Okay, so here, so serial number, name, file name, path, okay, path, then okay, owner, okay, then okay, permissions, then okay, size, block size, okay, then okay, block numbers, okay, status. Okay, so leave it. Okay, so let's say this is the table structure. This is the table structure what we have. Okay. So now it will update here. Serial number 1. Okay. File name is sample1.txt. Path. Okay. Project 1. Owner. Okay. Venkata. Permissions. Read, write, and execute. Size. What is the size of the file? 256 MB. Okay. Block size 128 MB.
128 MB.
Block numbers. Okay. So BLK 001,
001.
BLK 002.
002.
Here, okay, see, it is the same process here also, right? Even in the normal storage also. Okay. But okay, here this is also stored the same block numbers. Okay. But since all these are from the same disk, okay, no need to maintain the disk number. Okay. But here, okay, block number, okay, so where suppose if I say only block 1, block 2, so again, okay, in which hard disk I need to check for block 1, block 2? That is the reason. So here, okay, disk 5 colon block 1, okay, disk 6 colon block 2. Is it fine now?
Yes, sir. No.
Huh?
Yes, sir.
Okay. So now how my file is written now? Okay, where metadata is written now? Is it written in the place where actual data is available or in a separate hard disk?
Sir, you separate this one.
Separate
Centralized
hard
data.
disk, okay.
Yeah.
So in this scenario, metadata is stored in the master disk, and okay, actual data blocks are stored in worker disk.
Hello.
Understood? Sir, one second. I'll come to you. I'll give you option chance to ask questions. Okay.
Okay,
So
sir.
now tell me, okay, what is the user space in this disk space?
User space is
128.
128, 126.
128 MB.
Yeah.
Here, 128 MB. Understood? User space. And free space may be, okay, 4 point, okay, so 19 point, okay, 8 GB. Understood?
Yes, sir.
Okay, so now it is written, okay, writing algorithm has successfully written the blocks here, updated the metadata here. You see, blocks are written in separate hard disk, and okay, metadata is updated in separate hard disk. Okay, so once done, then close the writing algorithm. Did they change too many changes, guys? Did they make too many changes? See, here, initiate the algorithm, initial same. Okay, so compare the free space on the single disk here. Okay, and here free space on the logical storage. Okay, if disk is having enough free space, okay, if logical storage is having enough free space, check where the free blocks are available. Okay, so here where the free blocks are available, where 4 KB blocks are available here. So here, okay, check for which disk is having free space, more free space. Okay, then split the data into here. Okay, split the data into 4 KB pieces. Here, split the data into 120 MB pieces. 120 MB pieces. Okay, and okay, here, so it is not giving any block name. It is directly block names are already available, so it will put in the store the blocks actually. But here, what it will do, it will give a separate block name because okay, you cannot store a piece of data into any disk without a name. So that is the reason here it is giving a block name like this actually. Okay, and it is asking now writing algorithm is asking worker disk, hey, you write block 1. Okay, writing algorithm is asking worker disk, you write block 2. Okay, so now tell me, so worker disk, okay, will write block 1 and worker disk 6, okay, worker disk 6 will write block 2. Okay, now can both write parallelly? Okay, is there a rule that after writing block 1 only block 2 should be written?
No, sir, we can write parallelly.
So, see, so piece 1 is okay, your piece is your piece, my piece is my piece. Okay, you are disk Y, I am disk 6. Okay, you write your piece of data, I write my piece of data parallelly. I don't need to wait for you or you don't need to wait for me. Correct?
Yes, sir.
First of all, okay, does this worker, okay, disk 5 knows that, okay, so there is another piece of data here.
No,
my
sir.
continuation piece is here.
No.
So disk 5 doesn't know that, okay, block 1 continuation piece is block 2. Or okay, disk 6, okay, doesn't know block 2's previous block is block 1. Okay, see, disk 5 will be thinking that, okay, I have some data file which, okay, data which is called as block 1. The name of the data is block 1. So this 6 is thinking that, okay, I have some data. The name of my data, the file name of the data is block 2. Understood? Okay, so now all these disks are controlled here. Okay, the blocks are interconnected here, okay, using this centralized file allocation table. Okay, understood, guys?
Yes, sir.
Okay, so inside centralized file allocation table, I will have the link between your original file and the block numbers along with disk numbers. Got the clarity now?
Yes,
Huh?
sir. Yes, sir.
So now, okay, now if you write the second file, same thing, maybe second file pieces, okay, may go to this disk. Yes or no? So one fine day, okay, all these actual disks will become full. Correct or not? When
Yes,
these
sir.
actual disks are full, what I will do, I will add, okay, few more worker disk to the logical disk. Understood? Now, is there any concept like, okay, this is end of, okay, this is the maximum storage I can have?
No, sir.
No concept at all. Okay, no concept at all. Okay, see, you can add unlimited worker disk, guys. Unlimited worker disk. Now you will never say that, okay, you never feel that, okay, hey, I am running out of storage. If so, if your disk are existing worker disk are full, add, okay, some more worker disk. And okay, again, okay, is there a rule that, okay, all the worker disks of same size?
No, sir.
There is no rule. Okay, so like how, okay, when I say a team, okay, so do you think, okay, in the team everybody will be of the same age, same height, same weight? No.
No, sir.
No, sir.
So we have 10 members team. Okay, so 10 members means, okay, in the 10, okay, some may be having, okay, equal height, okay, some may be having equal weight, okay, so like that. Okay, so there is no rule that, okay, all the hard disks should be of same size. First thing, of same company also. One hard disk can be Samsung, one hard disk can be WD, one hard disk can be something else. So there is no rule that, okay, each and every hard disk should be of the same company or the same size. End of the day, if it is part of worker disk, that's enough. Okay, it is part of this logical storage, that's enough.
So the same time.
Okay, so now questions, sir. Okay, so now questions, please.
Sir, you said that in
Sir, voice is breaking, sir. I don't know whether it's only for me or for others also. Who is talking first of all?
Sir, Nandu here.
Nandu sir, tell me.
Yeah, sir, you said that in logical storing, data is stored in some or in one disk, and actual data is stored in some other disk. You said that, right?
Yes, sir. Yes, sir. Yes, sir.
You mean to say here you have altogether 7 hard disks, right?
Yes, sir. In that, one is master disk, remaining are worker disks.
Okay, sir, that is my doubt actually. So
Yes.
altogether in all hard disks, the metadata is stored in one master disk.
Sir, see, again, okay, see, each worker disk has its own metadata, right?
Yes, sir.
Okay. Now you tell me, okay, fine. Okay, now I will come to this part, okay? So, okay, now you see this picture, you will understand now. Okay, now I want to write, okay, a file, okay, sample.txt of 500 MB file, okay? So now here, okay, so I have 5 disks here. In that, one is master disk, remaining under worker disks, okay? Master disk and worker disk. Is it clear?
Okay. In
Yes,
every
sir.
hard disk, the hard disk itself behaving like master and worker, right?
Exactly. So one hard disk is behaving like a master disk, and the remaining hard disks are behaving like worker disk. Okay. And again, okay, since I'm connecting all these things into a single logical storage, are they changing their characteristics? What is the characteristic of a hard disk? Every hard disk will have their own metadata, actual data, correct?
Yes, sir.
Okay. So in the same way, when I write block 1, okay, of 128 MB, end of the day, how this disk will store this 128 MB piece? The disk will further convert into 4 KB pieces.
Okay.
Understood? Okay.
Yes,
So
sir.
this is the, it means okay, what we have done, okay, we created a layer on top of all these disks. Understood? Okay. So this is a layer here. This is the storage layer. Okay. You are giving the file to storage layer. What the storage layer doing? Under the storage layer, okay, you have master disk and worker disks. Understood? Okay. So okay, what this classical storage is doing, or writing algorithm is doing, okay. So it is dividing the file into pieces. Okay. If I have 500 MB file, how many pieces I will get? Okay. So first, okay, the piece size should be, okay, 128 MB. Okay. So the first piece 128 MB, second piece 128, third piece 128 MB, last piece is only 116 MB, because okay, that's where, okay, 500 MB file is over. Okay. So now for the first piece, it has given the name BLK1. Okay. For second piece BLK2, third piece BLK3, and fourth piece BLK4. Okay. And okay, this is asking each disk. Okay. So it is asking worker disk 1, hey, you write BLK1 here in your storage. Okay. So now, okay, till this, it is logical storage. Now the data is entering into physical storage. Correct or not?
Yes, sir. Correct.
Okay. How the data will be written to physical disk?
4 KB pieces.
Whatever you write, okay, into physical disk, that will be divided into 4 KB blocks, right?
Yes, sir. Yes, sir.
Understand? Okay. So now, okay, now, so this is your 4 KB, 4 KB. Okay. End of the day, every block will be further divided to 4 KB pieces. Okay. So now tell me, guys. Okay. Now, okay, you have metadata here, right? If I open this metadata, what you will have? If I open this metadata, okay, what you will have?
And that 4 KB blocks details, sir.
This is centralized metadata, right? This is centralized fact.
Yes, sir.
This is centralized fact. Okay. But this is normal fact. This is a, okay. So, okay, Worker disk fat. Disk 6 fat. Yes or no?
Yes, sir.
Okay. Inside this one, what I will have? Okay. Tell me, what is the file name I will have?
No, sir. I think.
Is it sample1.txt or BLK002?
Yes, BLK002.
See, for worker disk, okay, the piece of data is a file.
Yes, sir.
What is the name of this file?
Block 2.
Block 2. Okay. So path, let's say this one. Okay, who has written Venkata? Okay. So this time, okay, what is the total size? 128 MB. Okay. So now what are the blocks used here? Okay, 120 MB. Okay, it means okay. So B. Okay. So okay, 65 to okay, B. Some this one. Understood?
Yes, sir.
These are 4 KBs.
Yes, sir.
Okay. See what I'm trying to say here, because okay, because these disks are participating in the logical storage, they are not changing their characteristics. Are they changing their characteristics?
No, sir.
No.
It's not
Okay.
changing.
See here, okay, here what okay, writing algorithm is doing? Writing algorithm is dividing the data into pieces. Okay, and each piece is given to disk as a file.
Yes, sir.
Understood? Okay. So disk 6 is treating this piece as a file with the name BLK2. Okay. And disk 5 is treating this piece of data as a file with the name BLK001. Understood?
Yes, sir.
Okay. So now this is the metadata inside worker disk. Okay. But okay, for all these disks together, okay, we have one metadata. Okay, that is centralized fat. What is there in centralized fat? This is overall metadata of, this is a logical storage metadata. Yes,
Yes,
or
sir.
no?
Yes, sir. Yes, sir.
So this is okay, individual disk metadata. Okay, but this is logical storage metadata. So this is okay, individual disk metadata, which is nothing but file allocation table. Okay, this is logical disk metadata. Understood? So it is called a centralized fat. Okay, this is called as a just normal fat. Okay, so this is okay, individual disk fat. This is centralized fat, logical disk metadata.
Sir,
Now, okay, in the same way, if I open okay this metadata file here, okay, I will have file name as BLK001. Yes or no?
Yes, sir.
Now questions,
sir,
please.
it's a small doubt, sir. So now you cannot store actual data in master disk, right?
Yes, you are not storing okay any actual data in the master disk.
That is meant for centralized fat, right?
Exactly. That is meant, that disk is only meant for centralized fat file.
Okay. Okay.
So here, okay, now if I go to master disk doesn't know that it is a master disk. As per master disk, centralized fat is the file. Correct?
Yes, sir. Yes, sir.
Yes.
So as per master disk, okay, centralized fat is a file.
Yeah.
Okay. As per worker disk, block 1 is a file. As per worker disk, block 2 is a file. Yes or no?
Yes, sir.
But okay, they don't know. See here, end of the game changer is this one. He is the one who is playing. Okay, this software is the one who is playing this game.
Okay.
Understood?
Okay.
Yes, sir.
Okay. So this software is the one okay, who is making okay, everybody to work as a team. Understand?
Yes, sir.
Okay. And again, okay, even they're all working as a team. Are they losing any of their characteristics? Are they changing any of their characteristics?
No, sir. Not changing.
No changing anything. Are you clear now? Or any questions, guys?
Clear, sir.
Clear, sir.
Sir, in master disk metadata, which information, sir, available?
This is the information, sir.
This.
Okay. Now, Venkata has written the sample one test, right? Okay. Now, okay, how the reading algorithm will work now? Now, reading algorithm. So Venkata want to read. Venkata want to read. sample 1.txt back. Okay. So now, okay, we'll run a command. This command, okay, will invoke reading algorithm. Yes or no?
Yes, sir.
Now, okay, whom reading algorithm will contact now? In case of normal hard disk, okay, so reading algorithm will contact whom first?
Centralized flat, sir.
Okay, in the normal hard disk.
I mean metadata, sir. Metadata.
Metadata.
Metadata. File allocation table. Yes or no?
Yes, sir.
Okay. Okay. So here, okay, in case of normal disk operation, disk read operation, okay, how it works? Okay. How data is read? How data is read from physical disk? Okay. So initiate the reading algorithm. Yes or no? Initiate
Yes, sir.
by double clicking on the file. The file or some command or using some command. Okay, initiate the reading algorithm. Okay, so here, okay, reading algorithm, okay, I'll make it like RA reading algorithm. Okay, for the second step, okay, RA. Okay, RA. Okay, check.
And,
RA checks for
meta.
checks for file. Checks the file entry in the
Metadata.
in the metadata. FAT. Okay. Then, okay. So then, if found, okay. Okay, found. Okay, so read the block numbers from metadata from
Metadata.
entry. Okay. Okay. So now it got the block numbers. Read the block numbers from metadata entry. Okay, now the block numbers. Okay, now, okay. So ask disk header to read the blocks. Okay. So now, okay, it's okay. So disk header will read the block. Okay. So, okay. So, okay. The block number from metadata entry. Okay. RA asks disk header to read the blocks. Okay. So fifth point. Okay. So disk header will read the blocks and hand over to RA. Okay. 6 point RA will merge all blocks into one and on the screen. Okay. 7 point close RA. Yes or no, sir? Okay.
Yes, sir.
This is the reading algorithm. Okay. Physical disk. Okay. Now how the same thing will work from logical storage. Initiate the reading algorithm by double click on the file or using some command. Okay. So now writing algorithm is the file entry in the metadata or where?
Centralized metadata. Yes.
Which is nothing but a decimal file. Okay. Okay. So, array check. Okay. Now where array is checking? For logical storage, where is the metadata? For
Master.
logical storage, metadata is in centralized FAT. Yes or no?
Yes, sir.
Okay. This is the now reading algorithm will check in the centralized FAT. Okay. So if found, reading algorithm read the block numbers, okay. Block numbers, block and disk numbers from the metadata entry. Okay. It will read the disk and block numbers. Block numbers from the metadata. It will read disk and block numbers from the metadata entry. Okay. So now this reading algorithm understood that okay, disk 5 block 1 is there, disk 6 block 2 is there. Yes or no? Huh?
Yes, sir. Yes, sir.
Okay. So now RA ask disks, not disk header, disks to read the 5 blocks. Here it is asking, RA is asking disk header, okay, but it is asking each disk. Okay. Reading algorithm is asking disk 5, hey, read BLK5 and give it to me. Okay. Reading algorithm is asking worker 6, read block 2 and give it to me. Okay. So now, okay. So disk, okay, each disk, okay, will read the block and hand over to RA. RA will merge all the blocks into one and show on the screen. Close RA. Okay. Now, when reading algorithm is asking, okay, so first reading algorithm is contacting centralized FAT. From centralized FAT, it is checking for the file entry. Okay, and it is understood that okay, this sample1.txt is divided into 2 pieces. First piece is with the name BLK001, and second piece is with the name BLK002, and first piece is in worker disk 5, second piece is in worker disk 6. Okay, with this information, reading algorithm is contacting disk 5 for block 1 and disk 6 for block 2. Okay, so can reading algorithm directly go to this? Okay, directly go to any worker disk? No, right?
No, sir.
No, sir.
Okay, so reading algorithm if directly goes to worker disk, okay, then it has to check each and every disk where BLK1 is available. That
Yes,
is the
sir.
reason reading algorithm is contacting centralized FAT and checking for disk numbers and block numbers. With this information, it is contacting particular worker disk and asking, hey, you give me block 1, okay, and you give me block 2. Understood? So here, okay, so here what okay, 48 blocks. Okay, so here what I will do, okay, so physical disk here. Okay, so fine, clear. Yes. So now each disk will read. Okay, now tell me, okay, so here, okay, if you put everything in one hard disk, okay, this one hard disk will read entire data, correct? But here okay, my data is read by two hard disks parallelly. Yes or no?
Yes, sir.
So this is reading block 1 and this is reading block 2. Okay, so this is giving block 1 to reading algorithm. This is giving block 2 to reading algorithm. Okay, now reading algorithm is merging block 1, block 2 and creating one single piece and okay, showing on the screen. Any questions?
Sir, in master disk, like worker disk, there is some metadata, right? Master disk.
Master disk. Okay.
Yes.
Metadata, yes.
Yeah. How it utilizes the master disk?
Sir, okay, as per master disk, okay, centralized FAT is a file.
Okay.
Yes, sir. Yes, sir.
Okay. Now, if you open master disk metadata, okay, you will have like this.
That means the metadata of remaining all worker nodes will stored in metadata in the master disk, right?
Here, individual disk. Okay, so master disk metadata. Yes or no? So inside master disk metadata, as per master disk, okay, centralized FAT is a file. Yes or no?
Okay. Okay.
Yes, sir. That means remaining workers disk metadata will be actual data for master disk.
Remaining
Worker
Yes.
disk metadata will be actual data for master disk.
no, can you come back? Okay, I'm confused.
That means, sir, I think the same doubt I am having. So the metadata of all worker nodes stored in metadata of master node or actual in actual data of master disk.
So see here, okay, see here, metadata of each worker node will store information about, okay, actual data blocks. Sir, each worker disk metadata will contain the block numbers. Yes or no?
Okay.
Yes, sir.
Okay, okay. And okay, in the same way, metadata is fat, okay, will contain the centralized fat. Okay, but okay, inside centralized fat, what I have? Sir, inside this one, we have this entry. Inside this one, we have file entries.
Oh no, got it, sir.
Okay. Inside this one, okay, inside this master disk metadata, we have information about centralized file. Inside centralized file, information about your actual files.
Yes, sir. Now clear, sir.
Clear.
Sir, why it's creating the block 1 and 2 in worker disk 5 and 6, it can create in 6 and also in 5?
Yes, it's pure decision of writing algorithm. Think like that at this moment. Understood, sir?
Hello?
1 second, sir. 1 second. Okay. So now, what is there inside this one? Centralized file. Yes or no? Okay. Okay. Inside this metadata, we have block numbers. Okay. But okay, the combination of this, okay, all these things will be available inside the centralized file. Okay.
Yes, sir.
Any questions? 1 second, guys. 1 second. Yeah, guys. Who is this? There's a lot of noise. Santosh. Okay. Sir, any questions on this concept?
Sir, one doubt, sir.
Yes, sir.
Sir, why it's creating the block in worker disk 5 and 6? It can create in 5. The two blocks can be created in worker disk 5 or in
But
worker
okay,
disk
see,
6.
but here, okay, so suppose, okay, if I block 2 also here, okay, what in case, this is what you are saying, right? Sir, I have enough space, right? Why can't it create block 2 also here only, correct?
Yes.
Then, okay, where is the parallelism will come here? So, entire load, okay, you are giving to 1 disk only, right? So, you give it to 2 disk. The load, okay, you give it to 2 disk. Parallelism. Where is the, okay, then, okay, what worker disk 5 will do? Okay, it will write block 1 first, then it will write block 2 second. But if I give it to different worker disk, okay, so disk 5 will write block 1, disk 6 will write block 2 parallelly.
Yes, sir. We can minimize the time. I mean,
time, right? Okay, so let's say to write block 1, it is taking 5 minutes, and write block 2 5 minutes. Okay, just giving example. Total, if you give it to 1 disk, it will take 10 minutes. if I give 2 disks, okay, this will write this, both will start parallelly and both will complete parallelly. So it will take only 5 minutes.
Sir, that means so when any file is being created, all the blocks will be created in different worker disks.
Exactly, sir. Different worker disks, not in single disk. Your data will never go and sit in the single disk. It will be scattered across available physical disk, worker disks. Okay.
Okay, sir. Okay.
So this is the concept. Okay, who introduced this software? Is introduced by Google. And okay, do you know what is this name of this concept? Not software, guys. Okay, the concept is introduced actually. Okay, so the name of the concept is distributed file system. Okay, what is distributed file system? Okay, this is a standalone file system actually. Distributed file system is your data in the standalone file system. Your data will be stored in single hard disk. When I say distributed file system, your data will be split across multiple hard disks. It will be split into pieces and stored across multiple hard disks. Okay, this is called as distributed file system. Okay, so guys, okay, so I guess continuously talking. I don't know how many people are feeling interesting or not. Okay, I hope it is interesting, the concept. So these are all something new concepts actually. Okay.
Yes, sir, it is interesting.
Yes, sir.
Sir, okay, so
Yes,
we are
sir.
all
Interesting.
talking cloud, okay, all advanced technologies, right? Okay, all those advanced technologies are babies of these concepts. Understand? And these concepts, okay, you will understand those concepts well. Got it? If you don't understand the basics, what you will understand cloud? If somebody teach you cloud, huh? Okay. So these are the origins of all those things actually. Okay, so if no questions, okay, we'll stop it here, guys. Okay, thank you so much, and okay, see you all tomorrow.
Thank you. Sir.
Yeah. Any other questions from anyone?
Good morning. Hello.
Madam.
Sir, if as a user require, we can add number of work disks, right?
You can add any number of worker disks, yes.
Yeah. Then automatically metadata, that means master disk will going to fill one day. Then we can add master disks also, same like worker disk.
Okay, but here, okay, so master. Do you think okay? So you put 2 TB here like this, okay? Do you think how much? Okay, so here it is only information about your file, right?
Yes, sir.
Sir, no. How much size this will grow? How much size this will grow? This will hardly grows in GBs. Understood? Tomorrow, in case centralized fat is okay. So suppose okay, tomorrow, if centralized fat has become too much and it filled entire this disk, okay? So here I'm using 1 TB disk now, okay? Tomorrow centralized fat is full and it is occupying entire 1 TB. I will replace 1 TB with 2 TB. Okay, replacing one disk is fine, right? I'm not replacing, okay, 1 lakh, 2 lakh hard disk, right? Okay, think this, okay, like this, okay. So now I created a, okay, distributed file system with, okay, one master disk, okay, master disk, okay, and 5 lakhs worker disks. Okay, so you can go unlimited. Okay, as of now, think that I have 5 lakh worker disk. Okay, for this worker disk, okay, so the centralized fat is full. Then okay, I will be changing only one master disk. But okay, in the previous example, every time I'm changing my data, am I changing everything, right?
Yes,
I'm changing entire hard disk. But here, okay, I'm changing only master disk.
Master disk.
I will make it, okay. See, and one more thing, guys, okay. So in the world, okay, so okay, you take all the very big clusters, okay. Their metadata has grown up to only, okay, maximum, okay, 1 TB, max 1 TB, not beyond that metadata. Okay.
Okay, sir. Thank you, sir.
Yeah. Any other questions?
Sir, the centralized fact we will store in actual data of master disk.
Sir?
Centralized fact will be stored in actual data of master disk, right?
Actual data of master disk, yes.
Then how can we decide that will be stored in D65 to something?
Sir, your voice is not so clear, sir.
Master disk. Centralized fact actual
Sir, is it clear for others?
Storage media
No, sir, it's not clear.
might not be
It's not, sir.
stable as system memory. Memory swapping is limited by an available.
Sir, I guess, okay, two people are talking each other, okay? So please, you talk to me.
Sir, say the, you are replacing the, metadata master list, like you are increasing the size. Look, when you are increasing the size, like you are replacing this, will the data store, how will the data stored in the, this master list be secured?
Sir, what I will do when I'm replacing this master disk, okay, I will connect one more disk, okay, and I'll copy the centralized fact, okay. So now I will bring, okay, one more master disk, sir, here, okay. The size equal to 5 TB, okay. Okay, I will copy the centralized fact file from here to here.
Okay.
What is the problem?
No problem.
So as per master disk, centralized fact is the actual data, right?
Yeah.
Then okay, I can copy actual data, right?
Yes.
What is the problem? No problem at all. Okay, so fine, guys. Thank you so much. See you all tomorrow. Okay.
Thank you,
Okay,
sir.
sir. Thank you, sir.